Welcome back to Radian Measure, and this is part 3. First thing I'm going to do is a very pretty simple example here, determining cotangent of pi by 5. First thing you got to notice is pi by 5, that's not exact. Like there's no way I can take my special triangles and dredge up a pi by 5, so that's just kind of a little observation here. It's not going to be an exact answer. It's going to be as an approximation. And the next thing you got to do is, hey, this angle here seemingly is not in degrees. It doesn't say cotangent of 20 degrees or something like that. So make sure that your calculator is set to radians. Okay, if it's not in radians, you will get the wrong answer. Now, the next thing we're going to do, so these are a couple of little basic introduction steps. Now that we've got that out of the way, how do we proceed with this? Well, we're going to use a trick that we saw before. Most calculators don't have a cotangent button, so we have to do this. Cotangent is the same thing as 1 over tangent. So I go, okay, so I could do this. So now, making sure my calculator is in radians, it becomes a pretty straightforward button pushing on the calculator. And if you do that, you should get an approximate answer of 1.38. And that's about all we can do with this, okay, because it doesn't work in our special triangles. All right, on to the next example. The next one says the following. We have this point on the terminal arm. Okay, on the terminal arm. Okay, that looks pretty good. And then somebody says, determine what theta is. Determine theta. And they give us the following restrictions on theta. They want it to be between negative 2 pi and positive 2 pi. All right, as soon as you see this pi business here, what does that tell us? It tells me right away they want me to figure this out in radians, okay? Not degrees, okay? So if you're trying to figure out the angle here, it's got to be radians. And the restrictions here, this is kind of like in the degree world of saying negative 360 to positive 360, although we've got to be in radians. Right? This is just for my thinking on this. Well, I think what's a really good idea is to draw a picture. Pictures always give you a good framework, and so I'm going to draw myself a little picture here, set up my little grid. Okay, so let's say my terminal arm, I know it's 4 to the right and down 8, so it looks like it might be something like this. See, 4 to the right and down 8, so kind of steeper, something like that. And if I set up my little triangle here, okay, there it is. I know this is 4, and this is dropped 8. And theta has taken us like so, and there's my reference angle. So I'm looking at this, and I go, okay, how can I figure out what theta is? Now let's give it a name here. I'm going to call it beta or something here, my little reference angle, just so I don't confuse it with theta, which is actually the angle on the outside here. Yeah, and then I've got to make sure that I build it between negative 2 pi and 2 pi. All right, well, we'll deal with that later. First things first, I look at my little triangle and I see, hey, isn't the tangent of this beta angle equal to negative 8 over 4? Well, that's like saying it equals negative 2. Hey, I think if I just go tan inverse, I can figure out what beta is. So let's do that. Let's tan inverse both sides. So that gets rid of that. So this little angle beta is tan inverse of negative 2. Now make sure your calculator is set to radians for this, because our answer is supposed to be all in radians. If we do that, here's what the calculator spits out. I got negative 1.11. And that fits our little drawing quite well, right? There's angle beta, and it's a negative angle. So now all I got to do is go, okay, I know what this angle is as a negative angle here. Let's make sure it's in between negative 2 pi and positive 2 pi. Well, hey, beta works just as it is here as one of my answers. So one of my answers is negative 1.11. Now why is that? Because that's if I rotate in the negative direction, I'm allowed to go to negative 2 pi, which is a full negative rotation. And there it is. It's my little negative angle there. So that one's good. Now what about the other one that's in the positive side of things? All I'm going to do, it's actually pretty simple, is I know I want to end up here. What I want to do is start here and then add a full rotation. So I'm going to add 2 pi to that. If I do that, then I'm going to be in the positive zone, but it's also going to be coterminal to this location. So if I do that, I get 5.17. So these are my two thetas. That one is on the negative side, and this one's on the positive side, but they are both between negative 2 pi and positive 2 pi. And that is that. So now I can leave that alone and move on to my final example. In this example, we have the following point, negative 5, negative 1. It's also on the terminal arm. And let's see what's required of us this time. We're going to try to find theta, and we're told theta between 0 and 2 pi. So that's kind of nice. This time, I think we're only going to get one answer because we're not going into the negative zone. It's just basically in one positive rotation between 0 and 2 pi. Let's build a picture, shall we? This time my picture has to be in the negative world. And it looks like I got to be 5 to the left and down 1, so my terminal arm might look something like this. Okay, so if I build my little triangle, this would be the negative 5, and this would be the negative 1 here. And there's my reference angle. Let's call it beta again. All right, so using this little structure, what I can see is that the tangent of beta is equal to negative 1 divided by negative 5, which is positive 1/5. So go, hey, that's cool. Now let's hit it with a tan inverse. So if we tan inverse it, we're going to get beta is, so tan inverse of 1/5. And again, make sure you're in radians. And the calculator spits out 0.2. Now, you might go, hey, 0.2, but don't forget that's because this is pi, and then we've got to add the 0.2 to it to get the actual theta angle given where we've ended up. So to get my angle theta, I'm going to go pi plus that little rotation there, that little extra of beta. And so my final answer is 3.34, and that's in radians. And it makes sense, right? Because you want to be slightly beyond pi here. Pi being about 3.14, little bit beyond that. That's exactly what this is. So that's where I'm going to stop, and we'll catch you later.